Hello student and welcome for the MT2 design lecture, that is machine design 2 lecture. Today we will discuss the basic theory related to helical gear. Okay, just wait, I will share my screen. Okay, we will discuss on helical gears. So the helical gears, basically the teeth are cut at an angle which we known as a helix angle that with an axis of gear which is given. The helical gears are normally used either to transmit the power between two parallel shafts or to transmit the power between two non-parallel and non-intersecting shafts. In spur pair, the contact between two meshing teeth is theoretically uh, a line extending along their entire face width and parallel to the axis. This is nothing but a sudden line contact which result in an impact which turns that in a critical higher the dynamic load at the high pitch point velocity, and it also generates the noise. But in case of helical gears, the contact between meshing teeth begins at a as a point contact and gradually it extends as a line contact along the diagonal across the tooth. The gradual engagement results in a lower dynamic load as well as smoother and quieter in operation, even at a high pitch line velocity. Even though where the velocity get increases, still it is quite in operation as compared to the spur gear. So this is very important scenario while choosing the appropriate type of gear. As compared to the spur gear, helical gear having more costlier because it having an angular tooth uh, engraved. You can see into the figure. There are two types. Generally, there are two types. One is a parallel gear and second one is a cross gear. Okay, the parallel helicals are used to transmit power between two parallel shafts, which you can see in this picture, in this figure. Just a minute, I will show you. Okay, here you can see both gears shafts are parallel to each other and they can transmit their power. The parallel helical gears, the magnitude of helix angle is the same for both and the pinion and gear, but the ends of the helicals are opposite. You can see in the picture itself because the hands it means that जिस एंगल से ये कट किए हैं, अगर हम लोग पिनियन को देखेंगे तो वहां पे राइट हैंड कटिंग है, tooth cutting. Okay, but in gear it is a left hand. So one thing you must understood, while meshing two helical gears, one should be cutted in left hand threads, or can say left hand, and second one is cut right hand. So opposite helicals will be meet each other. अगर आप right लोगे तो ये match नहीं होगा. Okay, and in a cross gear, the cross gears normally used for transmitting the motion between two non-planar and non-intersecting. The cross helical gears, the pinion and gear may be having same or opposite hand of helix. The cross helical gears, the contact between two meshing teeth is theoretically a point contact. Hence, the cross helical gears are not preferred for power transmission. because they are used for motion transmission only, not for power transmission. Basic advantage of these helical gears, as we discuss, the contact of meshing teeth will start with the point contact and increase it gradually as a line contact. So smoother in operation and इसमें बहुत कम dynamic load भी आता है as compared to the spur gear. Okay, then the operation is quite smoother and quieter as they are engaging gradually. Then the contact ratio is high as compared with the spur gear, but having some limitations like it creates the axial thrust on the shaft and the bearings, and it is more costlier than the spur gear. When we are to avoid this axial thrust reaction, we can prefer for herringbone gear, that is called as a double helical gear. Okay, so the direction or equal and opposite thrust reaction will be balanced by each other. Next, basic terminology. So in a basic terminology, we will discuss few points because it's very important in aspect of gear tooth. Okay, so basically, most important thing is a helix angle. The angle made by a helix with the axis of rotation, or it is an angle made by a teeth with the axis of rotation. So it is called as a helix angle. Now it ranges for single helical gear. The helix angle is normally ranges from 15 degree to 30 degree, and in double helix, that is a herringbone gears, the helix angle normally ranges between 23 degree to 30 degree, and in some cases it is a 45 degree, but it is very rare cases. So the helix angle is not that much standard one. Depend upon the application, you can choose it properly. When two meshing teeth, when two meshing parallel helical gears must have same helix angle but opposite in hand. This is a very important. When the helical gear is placed on the surface with the axis vertical, if the teeth are inclined towards the right, it is called as a right hand gear, and if the teeth are inclined towards the left, it is called as a left hand gear. Okay, then transfer axial pitch, as is shown here, is the distance between distance parallel to the axis, that is distance between adjacent teeth, which is denoted by PC. Okay, then transfer speech, you can say it's a transfer distance between two successive teeth, that is a transfer speech. Then normal pitch, the distance between two face of adjacent teeth along the helix normal to the teeth, which is called as a normal pitch. So normal pitch formula is given. Now there are various transfer pressure angle, that is 20 degree involute pressure. That pressure angle we normally use, or normal pressure angle. Sorry, in the transverse pressure angle, the pressure angle measured in the transverse plane or plane of rotation is called as the transverse pressure angle. Normal pressure angle, that is a pressure angle in normal plane or plane perpendicular to the teeth is called as a normal pressure angle. The normal pressure and transfer pressure, there is a one relation, tan of transverse phi is equal to tan of normal phi divided by cos of psi. यहाँ पे जो phi है, phi it is a pressure angle, and यहाँ पे जो psi है वो है helix angle. Or next one is a equivalent number of teeth of gear. So it is actually equivalents per gear and virtual number of teeth. Okay, so helical gear is kinematically equivalent to an imaginary spur gear is a normal plane, that is a plane perpendicular to the teeth. This imaginary spur gear is normal plane which is kinematically equivalent to the helical gear. That is known as a equivalent spur gear. Okay, as shown in figure. यहाँ पे x and y यहाँ पे दिखाया है which is equivalent to. Okay, you can look at over here. आप यहाँ पे देख सकते हो इट इज अ हेलिक्स एंगल, इट इज अ हेलिक्स एंगल, बट इसको हमने ट्रांसवर्स प्लेन पे देखा तो यहाँ पे ये टीथ दिख रहा है, तो सिमिलरली टीथ यहाँ पे आपके एज अ एंटिटी ऑफ लाइक दैट स्पर गियर आपके वो टीथ जनरेट हो सकते हैं. ओके, तो we need to what we need to do, we need to find out the number of teeth on helix angle. Okay, then we need to find out the pitch circle diameter of equivalent spur gear. This pitch circle of helix is cut by plane as shown in figure, that is a neutral plane which is normal to the tooth which is shown in figure, that is nothing but a plane you have seen. Okay, AA. The corresponding section is an like a ellipse that it having a major axis equivalent to d by cos of psi. Okay, you can note it over here. There is one correction in this the equation. Instead of alpha, you need to use psi. Okay, because we have here the helix angle is denoted by alpha, so in all equation you need to consider alpha, which is nothing but here in this case they have mentioned, but we are using this equivalent symbol, that is a psi. Okay, so according to that your equation will be modified, that is a t is equal to t divided by cos cube psi. ओके, सो इसके लिए हमें पहले निकालना पड़ेगा r dash का वैल्यू. ओके, r dash वैल्यू that is equal to d divided by 2 cos square psi, then diameter, according to that diameter we can calculate. Now t dash, that is nothing but number of teeth उन्होंने बताया है, but as per our notification it is a z, so z dash, that is a number of teeth on equivalent spur gear, z dash is equal to pitch circle diameter of equivalent spur gear divided by module of equivalent spur gear, so that is nothing but d by d dash by m dash. ओके, तो d dash का वैल्यू आप यहाँ पे देख सकते हैं, you can put that value, that is a pi. Okay, that value you can put, and finally what we get, the z dash is equal to z divided by cos cube psi. Okay, so you need to change some nomenclature depend upon different type of books. The nomenclature gets changed. In PSG we are using helix angle as a psi, pressure angle as a alpha. Okay, so the minimum number of teeth, for finding the minimum number of tooth, you can use equation, that is for pinion or for gear. You can use a simple equation, zp is equal to 2 ha divided by mn sine square phi n. Okay, so we will discuss it while designing. Normally we are using same pressure angles which we have used in a spur gear. Then force analysis, there are two different forces which is acting, that is a tangential component, here it is denoted by WT, then radial component, that is a WR, and thrust component, that is a WA. Okay, so finally the tangential component is useful component and is responsible for transmitting the torque or power. This tangential component uh, is tangent to the pitch circle at pitch point, while the radial component tends to separate the two gears. This acts along the radial line through the pitch point and it is directed towards the center. But in a thrust one, the direction of axial component, that is a thrust component, of force acting on the helical gear depends upon whether the gear under consideration is driving or a डिविंग gear, वो कौन सा है वो डिसाइड करना पड़ेगा. Then the hand of helix of the gear under the construction consideration, यहाँ पे लेफ्ट राइट से कनेक्ट हो रहा है या फिर राइट लेफ्ट से कनेक्ट हो रहा है, डिपेंड अपॉन दैट. Then the direction of rotation of the gear, it's a clockwise direction or anti-clockwise direction. So there are few combinations are there, and based on that you need to find out the values. So tangential you can find out from equation, uh, power divided by velocity. Okay, so pi dn by 60 आप velocity find out कर सकते हो. Then power you can find out which is directly given. Okay, based on that you can find out the value of ft. Within radial component ft into tan of psi m. Okay, that is a pressure angle. But in case of helix angle, when we consider helix angle also, so it is changes, equation will be changed. We will discuss in PhD in a proper manner. Then the Lewis equation, we have already idea about the Lewis equation. Same equation we are using over here also. So rather than using only module M, here we are using normal module. Okay, so that is the difference which we need to be understood. Okay. Similarly, the equations are given in PhD page number 8.50. You can refer that also. Okay, so remaining way we are nothing but we are doing same procedure which we have followed with the design of spur gear. Okay, next type of gear is a bevel gear. Next type of gear is a bevel gear. You can see the basic arrangement of the bevel gear. Bevel gear is normally used to transmit the motion between the intersecting shaft. Bevel gear, where bevel gear is required. Okay, two intersecting shaft. The pitch surface of the bevel gear is a frustum of a cone. The tooth of bevel gear is maybe straight or spiral. Okay, you can see in a figure also. So there are two. So hence, based on this tooth profile, it is a straight bevel gear or spiral bevel gear. Normally, the shafting angle or shafting condition, we can say it's a perpendicular to each other. That is a 19-degree. Okay, so based on the angle, there are different types. When the equal bevel gears connected with the two shaft, those axes intersecting at right angle, it means that जो shaft का कनेक्शन है और उसमें जो एंगल जनरेट हो रहा है वो अगर एक्यूरेट 90 डिग्री हो रहा है, then it is called as a meter gears. And if the bevel gears connect two shafts, those axes intersecting at angle other than the right angle is known as a angular gear. When the bevel gear connected with the shaft and the is greater than angle is greater than 90 degree, then it is called as a crown gear. Okay, then it is a called as a crown gear. You can look at here. So it shows properly 90-degree angle, intersecting angle. In figure number A, it is show you the exact 90 degree, and this is a simple example of crown, which is the angle between two connection is greater than 90 degree. Okay, as I say, the spur, if tooth are properly cutted based on the straight line, these are the straight one, so it is called as a straight bevel. But you look at here, it is a spiral one. Okay, the tooths are cut in spiral manner, so that's why it is called as a spiral gear. So basic terminology, as we know, the important that is a pitch cone angle and all. So these are given shown in a figure. The cone containing the pitch element of the teeth is called as a pitch cone. Cone center, it is nothing but it is an apex of the pitch cone, or it is a point where the axis of two meeting gears intersect each other. Circular pitch circle diameter, it is the diameter of the pitch circle at the large end of the pitch. Then pitch cone angle, it is angle made by the pitch cone element with the axis of gear. Then pitch cone distance, it is the length of pitch cone element, that is called the pitch cone distance. Then module, it is a ratio of pitch circle diameter in millimeter at the large end of the teeth to the number of teeth. It is called as a module, that is a d by z. In this case also, similarly as we have already seen. Then backcone angle, backcone radius, face width, minimum, mean radius. So these are the further terminologies which we are using. Then a formative number of teeth based on the Treadgold approximation. So actually bevel gear is kinetically equivalent to an imaginary spur gear in a plane perpendicular to the tooth at the large end. As you've seen in a previous diagram, you can see hmm, in this diagram you can see the imaginary spur gear. You can see imaginary spur gear. Okay, in a perpendicular to the tooth of the large end as shown in figure. This imaginary spur gear is termed as a equivalent spur gear or virtual spur gear or formative spur gear. The pitch circle radius of this imaginary spur gear is equivalent to the back cone radius and the back cone radius and module equivalent to module. The practice of characterization the size and shape of bevel gear tooth as those of an imaginary spur gear appearing on the developed back cone corresponds to what you know, that is a Treadgold's approximation. The number of teeth can go in from further slide. Okay, the number of teeth, that is called as a virtual or formative number of teeth, that is z dash is equal to pitch circle diameter of equivalent spur gear, that is nothing but 2 rb divided by a module of equivalent spur, that is m. So zp dash, that is a number of teeth on pinion, is equal to twice rbp divided by module em. So substituting the values of R and M, what we get, ZP is equal to ZP dash is equal to ZP, that is the actual number of teeth on a pinion when we consider as a spur, divided by ZP dash, that is a number of formative tooth, and ZP is a minimum number of tooth on a bevel pinion. So ZP divided by cos of gamma P. Okay. So from this equation, we can find out the minimum number of teeth on bevel gear. Now about the strength. Similarly, there is a tangential force which is a useful component and responsible for transmitting the power. It is a tangent to the pitch circle through the midpoint of the face width. Its magnitude is normally F is equal to P divided by V. Okay. Similarly, to calculating the strength, we are using um, Lewis form factor and bending strength. Okay, so based on that, you can find out the strength of a bevel gear, which one is a um, weaker element. Then these are the loads: static load, wear load, and dynamic load, which we need to understand. From PhD page number 8.5253, we will get these equations appropriately. Then approximate the empirical relation with respect to the module. You can look at here. The next type of gear is worm gear, worm and worm wheel. You can say worm and worm wheel. So generally, the worm and worm gears drives are used to transmit the power between two non-intersecting and non-perpendicular axis shaft. The worm gear is used as a compact arrangement for high speed reduction ratio. Okay, generally the worm, which is gradually the driving member, is like a cylindrical form and resemble a trapezoidal or acme type of threads. That is a threaded screw. You can look at over here. Okay, you can see the worm here. So the worm may be left hand or right hand or single start or multi start to the cut. The worm gear is similar to that of a helical gear, which is you can see over here. Expect that the face is concave to the involve the worm. आप यहाँ पे देख सकते हो इसका जो फेस रहता है वो अप्रोप्रिएट उस कोन का जो एंगल है, हेलिक्स का जो एंगल है, which we are using on screw or you can say worm, तो वही एंगल यहाँ पे इंक्लूडेड है. So it is like quite small curve is provided over here. ऐसा स्ट्रेट नहीं है, यहाँ पे थोड़ा सा कर्व है. Okay. So generally, what importance is it is what important such kind of gear is. The worm drives are compact as compared to the spur. helical and beaver gear for reducing the same reduction ratio. मतलब इसका जो डिज़ाइन है वो इतना कॉम्पैक्ट है कि सेम रिडक्शन रेशो के लिए अगर आप स्पर हेलिकल या फिर बिवल के लिए यूज़ कर रहे हो तो ये उससे बहुत छोटा होने वाला है, छोटा होता है। इसमें जो रिडक्शन रेशो है इट कैन बी लाइक अ 17:1, सो 700 से आप डायरेक्टली 70 आरपीएम पे भी आ सकते हो। That much reduction is possible in the worm and worm wheel gear pair. Then the worm and worm wheel will be designed for irreversibility, or you can say self-locking. So it can be go in one direction only. If the efficiency of worm, because of this, the efficiency of worm and worm wheel is less than 50%. Then a few limitations are there. Its efficiency, as I discussed, it's very low as compared to the other gears. Then the friction is more because the worm are made with like a screw, and worm wheel is look like a gear. So there is a huge friction and heat dissipation can be occur. So normally the worm gear is made up of phosphor bronze, okay, so which increases the cost. Then the power transmission capacity of worm and worm wheel is very less, but it can reduce power very drastically. Okay, so as we discussed, we can use this kind of worm and worm wheel for a press application, converse application, then crushers, crane, elevators, ball mills, mixture, and extruders. As we discuss advantages, disadvantages of this, then basic classification based on the two type, cylindrical or straight worm, and the cone or double enveloped. So you can see in figure A1, 2, single threaded or double threaded, and you can see the difference between cone, that is the envelope one. If there is some misalignment in the shaft, okay, that also can be managed with the help of this cone or double enveloped worm and worm wheel. Then you can say faces of the tooth. First one is a straight face, second one is a hobbed straight face, and third one is a concave face. So these are few parameters which you can see. It is also having a helix angle as there is a thread. Okay, so the angle made by the helix with an axis of rotation, or it is an angle made by the teeth with the axis of rotation, that is called as a helix angle. Okay, which is shown over here. Then lead angle. Lead angle is the angle made by the helix of the worm with the plane perpendicular to the axis of worm. Okay, so here you can see the helix angle, normal angle, okay, and the lead angle. I will just highlight that lead angle. So this one is a lead angle. Okay, this is a helix angle because it's a normal angle hota hai. Then normal lead, that is a distance. Then what are the different type of systems we are using here? For worm, we are using 14.5 degree to and 20 degree. Okay, it could be single or double threaded, or you can say single start or double start. And in 20 degree It could be a triple or quadratic, a quadrat type of threaded. It's called the number of starts. About gear, yes, single or double threaded, it's at 14 and 20 itself, because it should be the parallel to this one. About the efficiency, it is a very important point. I never mentioned efficiency in other, because they are very efficient, and it can be transmit about 99% power transmission. But in case of this, as we discussed, it having a very low power transmission capacity, but it can reduce the speed. So that's why its efficiency is very uh, low. Okay, near about 50%. Now, what should be the यूज जहाँ पे रिडक्शन रेशो ज़्यादा चाहिए, स्लोली काम होना चाहिए, एट दैट in that area you can refer this type of gear. Okay, now how the designation is given. जब भी हम लोग वर्म एंड वर्म व्हील गियर को फाइंड आउट करेंगे, उसको सिलेक्ट करेंगे स्टैंडर्ड इक्वेशन से, तो उसको कैसे चूज करेंगे. सो इट shows in 4 digits, that is a n slash, then tg slash, then q slash and m slash, where first one is nothing but the number of starts of worm, then second one is the number of teeth on worm gear, then q is nothing but a diametrical quotient, and m is the module. So four factors you can find out. Okay, we will discuss further in briefly in a design. So selecting the material for worm and worm wheel. Generally worms are made from cast hardened steel, and worm wheels are made for phosphor bronze, because we can replace gear, sorry, worm gear, but and it is easily manufactured, so we can replace it easily. But phosphor bronze, it is first of all it's very difficult to manufacture, so and it's having a high cost, so इसका wear कम होना चाहिए, तो इसके लिए हम लोगों ने ये वाला यूज किया. And then why we are using such combination? Because phosphor bronze having a property that it is a harder material, and cast hardened steel is a softer material than that of a you can say phosphor bronze. Okay, तो यहाँ पे अगर wear ज़्यादा हो रहा है, friction ज़्यादा हो रहा है, तो कोई तो energy absorb करना चाहिए. So for that we are chosen this case hardened material, steel. Now about the design, we will actually discuss it in a proper method. Okay, then the failure modes, we can say simply failure modes. It is because of crowning. You can see a crowning involves the change in a caudal thickness of the tooth along the axis. This modification eliminates the edge loading problem due to excess misalignment and the deflection. Okay, you can look it in a proper manner. यहाँ पे curved है, मतलब at the end the thickness was less, it middle it is more thickened, and again at the second end it is less thicker. Okay, it's a crown one, and traditional one you can see here. Now pitting, as we know that if continuous impact is getting over there, and because of heat and friction there is a pitting could be occur. Then scoring, oh yes, it occurs because it having a various different shapes, and you can see the pinion, or you can say gear gets scored because of that helix here and here. You can look at here. Okay, so that's why we need to continuous provide a lubrication whenever the where wherever any gear you can choose at that gear to improve the uh, quality of working. You need to continuous apply or provide the lubrication. So that's is the basic theory related to different type of gears. Okay, we will discuss appropriate designs, okay, in the next lecture. Thank you.